For the rational function, determine the coordinate of the x-intercepts, determine the coordinate of the y-intercept, determine the equations of any vertical asymptotes, any horizontal asymptotes, and finally graph the function. Now, it sounds like a lot, and that can be intimidating, but each of these pieces is relatively easy to do, as long as you know the properties here. So, x-intercepts occur wherever the numerator of a rational function is equal to 0. So in this case, at x equals -7. And that happens at a point, so we'll write it as -7, 0. So go ahead and graph it. All right, then y-intercepts. Y-intercepts are really just as easy. All we do is we take the ratio of the constant terms, and so it's going to be 0 and whatever that ratio is, and in this case that's just 7. So 0, 7 is a y-intercept. All right, vertical asymptotes. These are very similar to x-intercepts in that we're looking for zeros of the denominator. So we just set the denominator to 0 and we get x equals -1. And we don't have to write this as a point because it actually is a line here, but we draw it in as a dashed line. And finally, horizontal asymptotes. What we do here is we compare the degrees of the numerator and denominator, and these happen to be equal because they're both degree 1. So when we have degree 1 polynomials, or degrees that are equal, there is a horizontal asymptote at the ratio of the leading term coefficients, which are both just kind of assumed to be 1 in this case. So y equals 1 is a horizontal asymptote. Now, the graph itself is sort of directed to infinity by these lines. So on this portion, we can either have this line or this, I shouldn't say line, this curve or the curve below. And the thing that's going to clue us in to which one is usually going to be locations of these points that are known. So we know it crosses the x-axis here, so that rules out this part of the graph. So the graph here consists of a line or a curve that bends toward these asymptotes like this. Similarly, on the other side, it wouldn't have the graph down here because I would need to have a crossing of this x-axis at some point. And I don't, but I do have this y-axis crossing over here. That kind of indicates that the graph is going to be in this upper quadrant.